Hello everyone. Good afternoon to all guys. Okay. So today we are going to start a new chapter, that is limit. Okay. So what we'll do, we'll just revise all the concepts. Very few concepts are in limit. Okay. And it's a topic, it's a chapter from which you can solve the questions in JEE mains easily. Right. So my suggestion, that's why we have selected these topics for your revision classes also. You can go through all the concepts and also solve a lot of questions on this topic, and then we'll able to solve some questions on limits also. Which questions will come in your JEE mains, we'll discuss about those questions, and especially we'll focus on those concepts or on those questions which already have been previously coming in your examinations, right? So I hope my voice is clear to all and my screen is visible also clearly to all. YouTube guys, you can respond in the chat box. Everything is clear. Everything is going smoothly. My voice is clear to all of you. Can you write in the chat box, YouTube guys, please? Everyone. Is my voice clear to all guys? Yeah. Right. So I hope my voice is clear to all. Okay. I think it's clear and okay also. So it's good to start our class now. Okay. So start करते हैं फिर limit. Okay. So we'll focus on 7 indeterminate forms first. Okay. So how many indeterminate forms in limit we have? 7 forms. One is infinity by infinity, 0 by 0, 0 into infinity, infinity minus infinity, infinity to the power 0, 0 to the power 0, and 1 to the power infinity. So how we can evaluate when the limit is in the form of such type of form? Okay. So how we can evaluate the limit? Okay. So don't think about like that. When you have the form is like infinity by infinity, that does not mean that it's accurately infinity by infinity. It's approaching to infinity upon approaching to infinity. Like similarly, you can say it's the numerator approaching to 0 and the denominator approaching to 0. It's not exactly equal to 0, right? So these are the 7 indeterminate forms on which we'll solve some questions also. Basically, we'll focus on previous year questions and we'll solve some previous year questions in this class. Okay. So let's start. First, all of you know 3 methods, 3 famous methods. All of you know these things also. First one is how we can solve when the limit is in the form of 0 by 0. Okay. So direct substitutions also you can you can find the limit when you have a finite limit. Suppose like some examples, very simple examples, you can take limit extending to 2x square plus 2. So this limit is actually for 6, right? Okay. So this is my finite limit. Okay. So when the limit is in the form of 0 by 0, so how many methods we know to solve or to evaluate the limits? One is factorization method. Okay. First one is factorization method. Second one is rationalization method. And the third one and the most important portion, that is binomial approximations. Okay. So all of you know how to factorize, how we can evaluate the limit by 5 factorization methods. Like simply you can take limit extending to 0. If I'll ask you to find the limit of, just a minute. If I'll ask you to find the limit of when extending to 0, x square minus 4 by x minus 2, right? So here, how we can evaluate the limits, actually this if you directly substitute the x as 2 here, it will be in 0 by 0 form. But so how you can evaluate this limit? Just you can factorize the limit given function. You can factorize the given functions like x square minus 4 can be written as x plus 2 into x minus 2, right? So in the denominator also you are having x minus 2 will be cancelled out. So finally you are having x extending to 2 x plus 2. So limit becomes here 4, right? So this is your answer. When by using the factorization methods also we can evaluate the limit. Similarly, all of you know rationalization method, like when in the given functions you are having the under root or power as 1 by 2, 1 by 3, 1 by 4. 1 by 2 basically we are having the square root portion, bala. Like suppose like that limit extending to 2 x on root of x minus 2 upon on root of x minus x plus 2. So how we can find the limit of this type of in these situations? Like this is actually 0. We can take another examples also. So in such type of functions or in such type of limits, what we have to do? We need to rationalize first. So rationalize karne ke baad we can evaluate the limits, right? Yeah, very good. So this is the method of rationalization, and the most important method, that is the third one, which is binomial approximations, right? So we will not go through all the derivation of binomial approximations. We'll just see what is the formula or how we can use the binomial approximation to evaluate the limits easily. So that is our motto, right? So let's start with binomial approximation. So what is binomial approximations actually, right? See here in the screen, on your screen, you have a formal definition or formal information about binomial approximations, right? So what is that? The binomial approximation is useful. You can see here, the binomial approximation is useful for approximately calculating power of sum of 1 and a small number x. It states that simply will not go through anything else. Directly what I'm saying, 1, if you have 1 plus x to the power alpha, and this is approximately equal to, this is approximately nearly equal to, that is 1 plus alpha, right? Yes, very good, Ganesh, very good, that's nice. So when you are having 1 plus x raised to alpha, this is approximately, we can write this as 1 plus alpha x, right? So you can ask, sir, why you are neglecting all other terms in the binomial expansions which you are having? Because if I'll put here the other terms also, they will be negligible when mod x is less than 1, right? When the mod x is less than 1 or mod of alpha x is less than 1, when mod x is less than 1, then mod of alpha x will be very less than 1. Then x and alpha may be real or complex, or x can be real, x can be complex, but we'll discuss about, or we'll consider the only real function. So remember, when you are having 1 plus x to the power alpha, then this is approximately equal to, you can say it is approximately 1 plus alpha x. Remember these things, and we will use these things to solve the questions. So how we can solve? Now let's solve one question. Okay, is it okay? Okay, Ganesh. So let's start. So this is the question in 2021, 27th July. Second shift me, I have a question here. You need to find the value of when limit extending to 0 of x upon 8th root of 1 minus sin x minus 8th root of 1 plus sin x. So how we can solve this limit? So what is the answer? Anyone can say? How we can solve the? We will use the binomial approximations here. I'm informing you, I'm giving you hints. Use the binomial approximation method. Okay. Use binomial approximation and try to solve it. Yeah. Anyone? Actually, it is easy. How we can solve it? Let's see. In only 3 to 4 steps, we can solve it. Okay. Chalo. So can we write this limit as? Limit extending to 0 x upon 1 minus sin of x to the power 1 by 8 minus 1 plus sin x to the power 1 by 8. We can write or not? Yes or no? We can write now. So all of you know, when as extending to 0, sin x also tending to 0. Yes or no? If extending to 0, sin x is also tending to 0. Yes. So by using the binomial approximations, in place of x here we have sin x. Okay, in place of x here we have sin x. So just using the binomial approximation extending to 0 limit. Very good Ganesh. That's nice. Good, very good. Okay, your answer is absolutely correct. Okay, YouTube guys, you can respond in the chat box. What is the answer you are getting? We are discussing the previous year question papers only. Okay, so this becomes x upon 1 minus, in place of sin x also we can write sin x, x also we can write, so 1 minus x to the power 1 by 8 minus 1 plus x to the power 1 by 8. By using, in place of sin x, I'm just using sin x, okay, in place of x. Okay, so now we know 1 plus x to the power n is approximately 1 plus nx. By using this result, can we write limit extending to 0 x upon 1 minus x by 8 minus 1 plus x by 8? Can I write or not? Yeah. Sin x is not equal to x, guys. Sin x is not equal to x. But here, from the result here, I'm not talking about sin x is equal to x, right? I'm just, as x approaching to 0, then sin x is also approaching to 0, right? Yes, it is approximately. Okay, I written here. I have written here as extending to 0, sin is also approaching to 0. Is that clear, Ganesh? Right. So to understand you better, I just replace sin x by x. Nothing else. You can write sin x, no problem. Okay. Okay. So now calculate the limit. If we'll put, now see, 1 will be cancelled out here, right? So limit extending to 0. What you are having now? X upon minus 2 into x upon 8. So this will be 4, x will be cancelled out. So what is the limit you are finally getting? That is minus 4. So this is the answer, and correct option is option C. Is it clear to everyone, guys? Is it clear to everyone, guys? YouTube guys, option C, very good. User 16, that's nice. Is it clear? Yeah. Shall I move to the next question? Vana Karmanath Das. Vana Karmanath Das. Wow. Okay. Shall I move to the next question? Okay. Yeah, very good. So next question, this is the solution. This is the long process. The method is followed by rationalization करके दुनिया भर का नाटक है. ये भी सही है, no problem. It is also correct. चलो ठीक है. Now the second question. Yeah, try it. Try this question, guys. What is the answer of this question? Anyone can say what is the answer? You two guys, you can respond in the chat box. I'm looking to your chart. See, I'm messaging you also. Hi, everyone. Yeah. Chalo. Anyone is getting the answer? Nothing? Okay. So let's solve one. Let's solve. So, but it is asking limit y tending to 0, 1 plus on root of 1 plus on root of 1 plus y to the power 4 minus root 2. Okay. So let's solve. Let's solve these questions. So this is asking limit y tending to 0, 1 plus y to the power 4 to the power 1 by 2 whole to the power 1 by 2 minus root 2 whole divided by y to the power 4, right? Yes. So now what we will do? Can we use the binomial approximation here, guys? Can we use the binomial approximation here? Yes, we can use. So use that. So limit y tending to 0, 1 plus y to the power 4 whole to the power 1 by 2. So this becomes by using the 1 plus x to the power 4 whole to the power n. So this will be, what will happen? So this will be 1 plus x to the power alpha becomes 1 plus x to the power alpha becomes 1 plus alpha x. So this becomes, similarly, this will be becomes 1 plus 1 by 2 into y to the power 4 whole to the power 1 by 2 minus root 2 upon y to the power 4. Can I write this or not? Can I write this or not, guys? Tell me. So finally, this becomes this. Okay. Now simplify it. Option, you are getting Ganesh. You are getting the answer. Okay. So limit a y tending to 0. This becomes 2 plus 1 by 2 y to the power 4 whole to the power 1 by 2 minus root 2 upon y to the power 4. Now, can we again use the binomial approximation? You guys respond in the chat box. Can you use again the binomial approximation here? Yeah. Can you use? You can say, sir, when we are having 1 plus x to the power something, then we can use the binomial approximations. But here we are having 2 plus 1 by 2 y to the power 4. Right? 2 plus 1 by 2 y to the power 4. So how we can use it? So yes, simple. If we'll take root 2 as common from the numerator, so what will happen? See here, if we'll take root 2 as common from the numerator, what will happen? Limit y tending to 0, this will be becomes root 2 1 plus, this becomes, if we'll take root 2 common, this becomes 1 plus y to the power 4 upon root 2 or 4. Yes, this becomes 4 na, yeah, whole to the power 1 by 2 minus root 2 upon y to the power 4. Now we can solve it. Now you can use the binomial approximation easily. Yes or no? Yes, we can use. So how we can use? So this, see, limit y tending to 0 root 2, this becomes 1 plus 1 by 2 into y to the power 4 by 4 minus root 2 by y to the power 4. See here, now this becomes root 2 to, yeah, so this becomes limit y tending to 0 root 2, if we'll take common root 2, okay, so this becomes 1 minus 1 plus 1 by 8 into y to the power 4, 1 by 8 into y to the power 4 minus 1 divided by y to the power 4. So 1 will be cancelled out. So this becomes limit y tending to 0 root 2 into 1 by 8 y to the power 4 upon y to the power 4. So y to the power 4, y to the power 4 will be cancelled out. So finally we are having root 2 upon 8. So what is the answer? It is given root 2 upon 8. Root 2 upon 8. So root 2 upon 8 क्या हो जाएगा? What is the answer? Root 2 upon 8, that is 1 by 4 root 2 हो जाएगा. This is the answer. Yes or no? 1 by 4 root 2. Is it your answer? Clear? Ganesh, is it your answer or not? 1 by 4 root 2. Is it clear or not? Root 2 by 8 into root 2 by root 2. कर लो भाई. So this will be 2 upon 8 root 2. So this becomes 1 by 4 root 2. Yes or no? Clear? चलो बढ़िया है, बहुत अच्छा. So this is the answer for the second question. So option is, correct option is option B. Right? So let's move to the third question. From the same concept I am taking, let's move to the third question here. You are having limit extending to 0, x plus 2 sin x. You two guys, you should respond here. Yeah. Limit extending to 0, x plus 2 sin x upon root of x square plus 2 sin x plus 1 minus sin square. Okay. So what we'll do? In this case, what we will do? Can I take, if we'll take, let I'm taking sin x as x. Okay, let's put sin x as x and solve it. Yeah, sin x as x, take sin x as x and solve it. So if we'll take sin x as x, this becomes limit extending to 0, numerator becomes x plus 2x, that is 3x, upon root of x square plus 2x plus 1 minus x square minus x plus 1. Right. Now try to rationalize this function. This is the method to solve this question. Try to rationalize this function. So this becomes root of x square plus 2x plus 1 minus root of x square minus x plus 1 divided by plus root of x square plus 2x plus 1 plus root of x square plus minus x plus 1. Now after after rationalization, so what you are getting? We are getting limit extending to 0, limit extending to 0, 3x into root of x square plus 2x plus 1 plus root of x square minus x plus 1 whole divided by this becomes x square plus 2x plus 1 minus x square minus x plus 1. Right. Now cancel. Okay, so x square will be cancelled out. 2x minus of minus x, that is 3x. 3x and ye ho jayega, 1 will be cancelled out. So in the numerator also we are having 3x, denominator also we are having 3x, right? So finally we are having, answer is 2, Ganesh. 2, answer is 2, not 2. Okay, so finally only we are having limit extending to 0 root of x square plus 2x plus 1 plus root of x square minus x plus 1. So this gives you 0, 0, 0, 1 plus 1, that is 2. So answer is 2. Option D is the correct answer. Very good, Ganesh. Very good. Answer is 2. Answer is 2. Option D is the correct answer. Yeah, Ganesh. No problem. It's okay. है ना? So है ना simple? Is it simple or not? Yes. So this is the third question we have solved till now. Third or fourth? Third question. So next question. Go to the next question, guys. Next question. What is the next question? थोड़ा top question में चलते हैं थोड़ा. चलो. This is the explanation. No need to go through it. Okay. So next 2020 JEE mains का question है. You need to evaluate extending to A. When extending to A plus 2x to the power 1 by 3 minus 3x to the power 1 by 3 whole divided by 3a plus x to the power 1 by 3 minus 4x to the power 1 by 3 is equal to answer. Equal to कुछ दिया है limit इसमें. Just wait. Limit. I need to check the questions again. Just wait. Oh, you need to evaluate. You need to evaluate. What is the limit? What is the limit? Only you need to evaluate. Okay. So the question is like given this limit extending to A plus 2x 1 by 3 and 3x this. Okay. So what we'll do for these questions, we are having here extending to A. So what should we do? We don't know what is A. So if I'll suggest you to take x as A plus x. Okay, take x as a plus s as extending to a, then s tending to 0. Is it or not? At extending to a, s tending to 0. So we'll convert this limit to limit extending to 0, a plus 3 into a plus x whole to the power 1 by 3 minus 3x 3 into a plus x whole to the power 1 by 3 whole divided by 3a plus x whole to the power 1 by 3 minus 4 into a plus x whole to the power 1 by 3. Now try to find the limit of this. First, I will suggest to open all the brackets. ब्रैकेट को ओपन कर दो जो भी है यूट्यूब गाइस. चल ब्रैकेट को सारे ब्रैकेट को तुम अगर ओपन कर दोगे, इफ यू ओपन ऑल द ब्रैकेट्स, व्हाट विल हैपन? लेट्स सी. So limit extending to 0, this becomes a plus 3a. This a, oh, this is 2 na. A plus 2a, that is 3a plus 3a. A plus 2a, that is 3a, and then 2h whole to the power 1 by 3 minus 3a plus 3h whole to the power 1 by 3 whole divided by, this becomes 4a plus h whole to the power 1 by 3 minus 4a plus 4h whole to the power 1 by 3. Right? Now after this what we'll do? ये तो हो गया हमारा. फिर से क्या करना है बेटा? So if we'll take 3a common from numerator and 4a common from denominator, let's see what is happening. So if we'll put limit extending to 0, take 3a as common from the numerator, that is 3a to the power 1 by 3. This becomes 1 plus 2h upon 3a whole to the power 1 by 3, because we need to apply the binomial approximations. That's why. So from here also we can take 3a as common, that this becomes 1 plus 3h upon 3a to the power 1 by 3. So in the denominator also I am taking 4a to the power 1 by 3. So this becomes 1 plus h upon 4a to the power 1 by 3 minus 1 plus 4h upon 4a whole to the power 1 by 3. This. Now, can you apply the binomial approximation to evaluate the limit, guys? Yes, you can or not? So from here you can visualize. Oh, the pen is not right. Let's see. Here we can, what we'll do? So limit extending to 0, a to the power 1 by 3, a to the power 1 by 3 will be cancelled out. So finally I am having 3 to the power 1 by 3. So उसके ये तो constant है मेरे पास. So let's forget about it. Now use the binomial approximation. So if we use the binomial approximations, what will happen? This becomes 1 plus 2h upon 3a into 1 by 3. That is 2h upon 9a minus, this becomes 1 plus 3 will be cancelled out. So h upon 3a, right? H upon 3a whole divided by, this becomes 1 plus h upon 12a minus 1 plus 4a, 4 will be cancelled out. This will be h upon 3a, right? So this is my limit till now I'm getting from the simplification of this. So now you can visualize here, you can see 1 will be cancelled out. Yes or no? Here from also here 1 will be cancelled out, right? So what we are having, limit extending to 0, 3 upon 4 whole to the power 1 by 3 whole to the power 1 by 3, and here we are having h upon a. From the numerator also it is coming h upon a common, and also from the denominator h upon a common. So if we'll take h upon a as common from the numerator, what we are having, 2 by 9 minus 1 by 3 whole divided by, from the new denominator also I am taking h upon a as common. So this becomes 1 by 12 minus 1 by 3. So h upon a will be cancelled out. So what we are having? So we are having 3 by 4 to the power 1 by 3. This becomes 9. So 2 minus 3, that is minus 1 upon 9. Okay, upon whole divided by, this is 1 minus 4, that is minus 3 upon 12. So finally what we are having, the answer will be 3 by 4 to the power 1 by 3 into minus will be cancelled out. This will be 1 by 9 into 12 by 3. So this will be 4. So 3 by 4 to the power 1 by 3 into 4 by 9, right? 4 by 9. So this becomes, this will be 3 to the power 1 by 3 upon 3 square into 4 by 4 to the power 1 by 3. So calculate it, and what is the answer you are getting? Tell me in the chat box what is the answer you are getting. Match with your options. What is your answer you are getting? Calculate this, and what is your answer you are getting? Tell me. The answer will be like this: 2 by 3 into 2 by 9 whole to the power 1 by 3. Right? 2 by 3 into 2 by 9 whole to the power 1 by 3. So what is the answer? You can calculate, yeah? You can calculate. 2 by 3 into 2 by 9. This is the answer. Option B is the correct one. Option B is the correct answer. Is it clear to all, guys? Vana Kurmanandas. Is it clear, guys? YouTube guys, you should respond in the chat box, everyone. Clear hai ki nahi? Yeah. Clear? Sure. Ganesh, is it clear? Yes or no? We have a lot of syllabus we need to cover. Is it clear or not? Just respond. इसमें कुछ भी नहीं था. Just we use the binomial approximations. Is there any doubt you can ask? Answer में यहाँ पे तुम्हें बस न्यूमेरिकल कैलकुलेशन करना है, nothing else. This is the calculations part. तो सही है. Clear है कि नहीं? Shall I move to the next? Everyone? Is there any doubt? You can ask. चलो ठीक है. So this is the answer. You can see here the calculation is like this. The detailed calculation is there available. Okay. Chalo, okay. Let's move to the next thing. Now we'll see how we can evaluate the limit by using some standard results, right? So results 1, first we know limit, when limit extending to 0, sin x upon x is equal to 1, right? Okay, and also we know limit extending to 0, tan x upon x is also equal to 1. You know these things. You need to remember all the standard results in limit. Remember these things. This is very, very important to solve the limit questions. Okay, limit extending to 0. All of you know these things, huh? Very simple and basic things of limit. And also you can see when you are having sin inverse of x upon x when extending to 0, this gives also 1. And limit tan inverse of x upon x when extending to 0, this gives also 1. Right? Okay? Clear? Sure. So this is these are my 4 standard results till now we have covered. One is when sin x upon x extending to 0, 1, tan x upon x extending to 0, 1, limit extending to 0, sin inverse of x upon x gives you 1, and limit extending to 0, tan inverse of x upon x is equal to 1. Clear? Chalo. Okay. So these are 4 standard results, we have more standard results also. Remember, limit extending to 0, e raised to x minus 1 upon x is equal to 1. Important hai. Okay. Limit extending to 0, e raised to x minus 1 upon x is equal to 1. And also limit extending to 0, a raised to x minus 1 upon x is equal to log a to the base e. This is equal to, also you can write ln a. So ln a is equal to, what is that? Log of a to the base e. So this is my natural logarithmic. Remember, when limit extending to 0, a to the power x minus 1 upon x you are having, then you must write in place of that directly, or you can substitute directly log a to the base a, log a to the base e, or ln e, or ln e you can say. Okay. Similarly, seventh one is log of 1 plus x upon x. Remember, what is the method to remember these things? Remember this. Limit extending to 0, log of 1 plus any box upon box. Then this gives you 1. Limit extending to 0, e to the power box minus 1 upon box is equal to 1. Limit extending to 0, a raised to box minus 1 upon box gives you ln a, right? And similarly here also, limit extending to a, x raised to n, box to the power n minus a to the power n upon box minus a gives you n into a to the power n minus 1, right? So these are my 8 standard results, and we'll use these standard results to evaluate the limits, or we can solve the limit questions very easy. So you need to remember all these standard results. Okay. कभी भी तुम्हारे पास when e raised to box minus 1 upon box है, तो ये 1 हो जाएगा. Log of 1 plus box upon box है, तो 1 हो जाएगा. And log of a raised to x और a raised to box है, तो ln a हो जाएगा. And if you have ln of limit extending to a, x raised to n minus a raised to n upon x minus a hai, then it will be n into a raised to n minus 1. So you have to remember all these limits or standard limits to solve the questions. They are very important. I always told you, or I am suggesting you to remember all these standard results. So let's move. Let's move to another question here. This question is from 2021, 31 August. So these questions actually asked twice or thrice in JEE mains actually. And so it's a very interesting questions. You can solve these questions by 2 to 3 methods also, right? So first we'll see by using the standard results how we can solve this limit. Okay, so let's solve. Limit extending to 0, sine square of pi of cos to the power 4x, cos की power 4x. Okay. So can I write this as pi minus pi of cos square x, cos 4x divided by x to the power 4? Can I write or not? Tell me, everyone. Can I write this as sine square pi minus pi cos की power 4x? Can I write this or not? Everyone tell me, by using the trigonometric identity, can I write this, guys? Yes or no? Let me know in the chat box how many of you agreed with my opinion. Can I write this or not? Ganesh is saying, sir, yes. Yes, we can write. Okay, so it's a very simple thing. Huh? Okay, so next, what I'm saying, limit extending to 0. So previously I told you, we'll solve the questions by using the standard results, right? So just to use the standard results, what we'll do? Sir, is that 4 pi square? Yeah, very good, Ganesh. Answer is 4 pi square. Good, that's nice. Okay, good. So limit extending to 0 sine square pi minus pi cos की power 4x upon x square. Okay. So to use the standard results like this, limit extending to 0 sine x upon x is equal to 1. We know this. So when we are having in argument of sine is x and in the denominator we are having x, then the result becomes 1. So in the given questions in the argument of sine square, we are having pi minus pi cos की power 4x. Right? Already we are having before x to the power 4. Right? So what we can do, if we'll write or if we'll multiply pi, if we'll multiply pi minus pi cos square x की whole square and divided by also pi minus pi cos square x की whole square, whole divided by before we are having x to the power. Now, is there any problem if we'll multiply pi minus pi cos square x की whole square and divided by also pi minus pi cos square की x की whole square? Is there any problem if I'll divide or multiply these things? There is no issues, na? Okay. So simply, if we'll do this, also we can write, because this is working as, you can see here, if this is working as my x by the standard results we are using, and this is my x. So here we are having square and also here having we are square. So this limit becomes 1 by using the standard results. Limit extending to 0 sine x upon x gives you 1. So what you are having finally, so limit extending to 0 pi minus pi cos square x की whole square by x to the power 4. Right? So now what we'll do? How to find the limit now? So this is if we'll put 0, then it will be 0 by 0 form also. So if I'll take pi as common, okay. So limit extending to 0, if I'll take pi as common, or this will be when pi comes to outside of the bracket, this becomes pi square and it becomes 1 minus cos square x, okay, divided by x to the power 4 whole square, right? So this becomes limit extending to 0 pi square. This can be written as 1 plus cos x ka whole square into 1 minus cos x ki, sorry, cos square x ki whole square, okay, divided by x to the power 4. Now we can see here what is happening. Now this becomes, see, this becomes 1 minus cos square x, that is sine square x upon x to the power 2. It will be limit extending to 0 pi square. So this will be 1 minus sine square x 1 plus cos square x the whole square divided by x square into sine square x by x to the power 4, sorry, x square. So this limit becomes 1. Now this becomes limit extending to 0 pi into, if we'll put 0 here, what will happen? 1 plus, this is also 1, so 1 plus cos 0. Sorry. This is 4, na? This is, here we are having square and this will be 4. So we don't need to take this here. So this will be x to the power 4. So this becomes limit 1. So pi cos 0 is 1. So 1 plus 1, that 2 square is 4. So answer is 4 pi square. 4 pi square is the answer. Clear? Answer is 4 pi square. Is that clear to everyone, guys? Now, Ganesh, is it clear? YouTube guys, you can respond in the chat box, everyone. Hi, Yeswant. Hello. Clear, hai na? Okay, if it is clear to all, let's move to the next question. Oh, there are some series expansions we need to remember. Okay. First is e raised to x. The series expansion of e raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Remember, this is the expansion of a raised to x. This is the expansion of log of 1 plus x, right? You can take a screenshot of all these series expansions. Take a screenshot. So series expansion actually will help a lot to solve the limit questions also. Okay. No need to go through all the how the series expansions happens in the later or higher studies. When you will do higher studies, then you will go through all the derivation of all these series expansions like e raised to x, a raised to x, log of 1 plus x, all these things, right? Okay. So don't worry about it. Just remember all these expansions. रट लो भाई. ठीक है. Simply what I am saying, याद ही रख लो दिमाग में. e raised to x का क्या होता है? What is a raised to x expansion? What is the expansion of log of 1 plus x? Similarly, a lot of expansions we are having. Sin x, cos x, tan x. Sin x can be expressed as a series. Cos x is also expressed as a series, sum of series. And tan x is also expressed as a series. And also similarly, tan inverse of sin inverse x. So all these 8 expansions, 10 expansions we are having here. You need to remember all this, how to apply this expansion in JEE exam. Yes, we'll solve questions. Okay, don't worry. So these are the expansions you need to remember. Okay, simply what I'm saying, sin x, just remember this one, this e raised to x, a raised to x, log of 1 plus x, sin x, cos x, tan x, remember these things. And also, if you can remember tan inverse of x and sin inverse x. And lastly, these are important, the binomial expansion, that is 1 plus x to the power n, and also 1 plus x to the power 1 minus 1 by x. Okay, so these are the series you need to remember, or these are the expansions you need to remember. So how can we use this series expansion when we will solve the questions? That is important. Okay, so how we can solve? So this is a question in front in your screen. Okay, this is a question in your screen. You can solve it. Okay, chalo, so let's solve. Huh? By using the series expansions, we can solve these questions. How? Let's see. Just if you took the screenshot of all these series expansions, so here we'll use 3 series expansions in these questions. One is, that is e raised to x ka series expansion. Another one is log of 1 plus x ki series expansion. And third one is e raised to minus x. Fourth one is sin x कोई जरूरत नहीं अभी यहाँ. So these 3 series expansions we need to remember. We will use here. So what is e raised to x? You can see here e raised to x, already I told you, 1 plus x square by 2 factorial plus x3 by 3 factorial. So see here, we can 1 plus x square, 1 plus x square by 2 factorial plus x cube by 3 factorial, all these things. And log of 1 plus x की क्या हो जाएगा ना, x minus x square by 2 plus x cube by 3 and so on, minus x to the power 4 by 4, all these things. So the third one is that is e raised to minus x. Simply you can take the minus sign here. Okay, this is the expansion na? Log, yeah, x minus x square by 2. Yes, okay. These 2 expansions we are using in this question. So let's see how to solve these questions. Use these expansions and try to solve. So in the questions it is given that limit extending to 0, limit extending to 0, alpha into x expansion में 1 plus x square by 2 factorial. I am just taking 3 terms. Because we need the values of alpha and beta and gamma. We need the values of alpha and beta and gamma. Okay, so you can see if we take the higher degree of x, or if we'll take x cube x to the power 4 upon 4 factorial, so this will be becoming very, very closer to 0. So that's why we are neglecting all the other higher terms, other negligible terms. I'm just taking up to 3 terms: alpha x into 1 plus x square by 2 factorial minus beta into log of 1 plus x square, that is x minus x square by 2. Thus, that's all. I'm taking 2 terms because I'm not taking x cube. X cube can be used. Alpha, yes, x cube can be used here because we have gamma also. That is plus x cube by 3 factorial. 3 to 3. That is 3 plus lambda into, sorry, gamma into x square into e raised to minus x. So e raised to minus x. That is, I am taking this only, 1 minus x. Minus x, 1 minus x. So e raised to minus x, 1 minus x minus x square by 2 factorial minus x cube by 3 factorial, all these terms. So I'm taking these terms, whole divided by, okay, whole divided by, but we are having x into sine square x. So x into sine square x, can you use here as extending to 0? So sine x is also tending to 0, right? So in place of x, I'm substituting x cube, x square, okay, sine square x. As x square tending to 0, sine square x is also tending to 0. So in place of sine square x, I'm taking x into x square, that is x cube. So this is my now the new limit. Now try to differentiate the coefficient wise or the variable wise. So first, what I am taking, limit extending to 0 when I will multiply alpha x with the first brackets, and when I'll multiplying beta with the second bracket and gamma with the third bracket, then the what are the coefficient of x square you will get? What are the coefficient of x square? So let's take first x. What are the coefficient of x you will get? If you multiply alpha x into with the first bracket, beta with the second bracket, and gamma with the third bracket. So what will happen? So alpha x into minus beta x. So alpha minus beta into x we are getting. Alpha x, when we are multiplying alpha x into 1, we are getting alpha x. When we are multiplying beta with x, that is minus beta. Alpha into alpha minus beta into x. Then plus, what are the coefficient of x square you are getting? So when you are multiplying alpha into x, we are getting alpha x square. When you are multiplying beta with x square by 2, we are getting beta x square by 2 plus beta x square by 2. So that means x square, if you take x square as common, so it will be alpha plus beta by 2, right? Similarly, if you multiply alpha x with x square by 2 factorial, it becomes alpha into x square x cube, yeah, alpha into x cube by 2 factorial, and this becomes beta into x cube by 3, and this becomes gamma into, here also we are having gamma na. When we will multiply gamma square into x, we are getting also another term, yes, with the coefficient of x square, that is x square we will take plus gamma, okay. Then plus, we will take x cube as common. X cube as common, this will be alpha by 2 factorial, alpha by 2, here we are getting minus beta by 3, minus beta by 3, then we are getting gamma minus gamma divided by x cube. So this is now we are getting. Now it is given that in the question it is equal to 10, right? This is equal to 10, it is given. So to make this limit as 10, so what should we do? हमें क्या करना चाहिए? What we'll do? So remember, if we'll put, suppose I'm taking alpha minus beta is equal to 0. So this gives you alpha is equal to beta, right? Alpha is equal to beta. And second thing, alpha plus beta by 2 plus gamma is equal to 0 if I'm taking. So finally here I'm getting gamma is equal to 2 alpha plus beta by 2. 2 alpha plus beta by 2 and minus now. So in place of beta, we can substitute alpha also. So this becomes minus 3 alpha by 2. Okay, so this becomes minus 3 alpha by 2. So, and the last one. This is equal to 10, it is given now. Okay, and the last one, that is alpha by 2 minus beta by 3 minus gamma if I am taking this as 10. So what will happen? So this becomes try it, alpha by 2 minus beta by 3 minus gamma is equal to 10. So this becomes alpha by 2 minus beta, in place of beta I am also taking alpha by 3 minus gamma is equal to minus 3 alpha by 2, that is 3 alpha by 2 is equal to 10. I am taking. Okay. Chalo. Okay. So if you are taking, then what is the value of alpha you are getting here by solving this? I am getting 6. This will be 3 alpha minus 2 alpha plus 9 alpha is equal to 10. So 3 alpha plus 2 alpha, 10 alpha is equal to minus 60. So alpha I am getting minus 6. So from here, alpha, the value of alpha I am getting minus 6 or 10 alpha is equal to 60. Na? This is plus. So alpha is equal to 6 I am getting. So if alpha is equal to 6, then beta is also 6. So if alpha is equal to 6, beta is equal to 6, then gamma is equal to minus 3 into 6 by 2, that is minus 9. So alpha plus beta plus gamma, what is the value of alpha plus beta plus gamma you are getting? That is 6 plus 6 minus 9, that is 3. Okay, so answer is 3. The correct answer is 3. Remember, this is a numerical questions asked in 2021 JEE mains question. Answer is 3. So alpha plus beta plus gamma is equal to 3. Clear? Chalo. Okay, so this is the this is one questions we have solved by using the series expansion here. Let's move to the next question. Ganesh, it is clear? हाँ sir, ये वाला question थोड़ा lengthy था. You can skip it. Okay, if you are getting any lengthy questions, you can skip it. Huh? So if you one thing is, if you remember the series expansion, if you remember the series expansions, it will be easy. So try to remember all those series expansions, then you can solve the questions, right? So let's move to the another question. We have another questions, but the thing is, those questions are from advanced level. So basically in JEE mains question, series expansion wala question itna nahi aata hai. Very rarely questions are asked from series expansion. If you can study, if you have time to cover all those, or already you have covered the series expansion wala portions, or you have solved a lot of questions on those things, then you can go through those things. Yeah, if you didn't cover all those things, or now you don't have time to focus on these things, then I will suggest don't go through it. So those concepts you are very much clear, you are very much comfortable with the concepts, go through those concepts and solve questions. That will be fine and great also, right? So let's move. How we can find, this is the next question. This, okay. How we can apply L'Hopital rule, okay? The thing is here, we'll study about L'Hopital rule, or L'Hopital rule, and the very famous rule, and it's a very, very useful rule also, right? Sir, as JEE April attempt is approaching soon, how to cover the coordinate geometry? First of all, did you gone through all the concepts of coordinate geometry, Ganesh? Before, did you cover all the concepts of coordinate geometry and conic sections very clearly? Yes or no? Some of are yet not covered. That means actually the coordinate geometry and conic section wala portion is a very big unit of your syllabus, right? At least 3 to 4 questions you will go, 4 questions you will get in your JEE mains examination, and the weightage of that unit is very high. So that's why my suggestion, now we don't have time to cover all those concepts in deeply, right? So my suggestion will be, don't go through all these things. Just focus on those topics for which on which you are very much clear, and you must understood all the concepts, and you are able to solve questions on these topics, right? Like previously we have covered in this JEE 2020 PIQ is enough, no? For coordinate geometry, it's not enough. It's not enough. Coordinate geometry, at least it will take a very big time to solve the questions. Okay, if you want to go through one thing, that is, you can go through circle also. Circle less sector, but if you will go through circle, then other 3 will be easy for you. Parabola, hyperbola, ellipse, like this. So simply don't go through the new topics now. Choose the easy topic and try to attend at least 8 questions, 8 chapters, and try to attend 8 questions in JEE mains. And if you are attempting, or if you are solving 8 questions or 9 questions in JEE mains correctly in mathematics, you are scoring above 95 percentile in mathematics. I already told you in the previous class, right? So try to focus on those topics. Those concepts are you are clear, you are able to solve the questions. Focus more, give more focus on those topics only. Okay, like I already covered reasoning, mathematical reasoning. We have covered statistics also. We have covered quadratic equation, complex number, permutation combinations. These are the topics from which you can solve questions easily, right? And now we are continuing the limit. Okay, let's come back to our concept, that is L'Hopital rule. L'Hopital rule, what it is saying, to solve the questions when the limit is in the form of 0 by 0 or infinity by infinity, right? So what is L'Hopital rule? Suppose f and g are 2 continuous differential functions. Continuously differential function at a real number c, such that then f of c is equal to g of c is equal to 0, and g dash c is not equal to 0. G dash c is not equal to 0. Then limit extending to a, f of x upon g of x is equal to limit extending to a, f dash of x upon g dash of x. If you are not getting limit here also, then again differentiate or take the double derivative, f double dash of x, g double dash of x. If you are not getting the finite limit here also, then you can move through the third derivative of limit extending to 0, f dot triple dash of x upon f triple dash of x. So when we can apply this rule? Now when the limit is in the form of 0 by 0 or infinity by infinity. Clear? Yes. Example, we are taking the first example here. Limit extending to 0 e raised to x minus 1 upon x. So the form is e raised to 0 is 1 minus 1, that is 0 by 0 form. So 0 by 0 form, here we can use the L'Hopital rule. So by using the L'Hopital rule, we can solve these questions. So what is it saying? So just this limit will be equal to limit extending to 0. Derivative of e raised to x is e raised to x, and derivative of 1 is 0. Minus 0 upon x is derivative of x is 1. So simply we are having limit extending to 0 e raised to x, that is e raised to 0 is equal to 1. So this is my answer. Clear? Clear? This is my answer. Clear, everyone? Okay, so this is the L'Hopital rule to evaluate the limit. So this is the best way when you are getting the limit is in the form of 0 by 0 or infinity by infinity. The best way to use the L'Hopital rule if it is applicable here. Okay, that is continuously differential function. Okay, okay, clear? Sure. Let's solve one question. Oh, this is the question. Now we'll solve. So what is the answer of this question? Can you solve it? See here. This question came in 2027 January. Limit extending to 2, limit extending to 2, 3 raised to x plus 3 raised to 3 minus x minus 12 divided by 3 raised to minus x upon 12, x upon 2 minus 3 raised to 1 minus x, right? So is it in the form of 0 by 0 or infinity by infinity? Let's check. If we'll put 3 square is 9, this will be 3. 9 plus 3, 12 minus 12, 0. Then this will be 3 to the power minus 1, 1 by 3. 1 by 3 minus 3 to the power minus 1 by 3. 0 by 0 form. Yes, it is in the form of 0 by 0. But to make it more easier calculation, just what I'm doing, I'm multiplying the numerator and the denominator with 3 raised to x. Okay, so after multiplying, what we are getting? So limit extending to 2, 3 raised to x into 3 raised to x gives you 3 raised to 2x plus this will be 3 raised to 3 minus 12 into 3 raised to x divided by this becomes 3 raised to x by 2 minus 3 raised to 1. Okay, so now we can see this is in the form of 0 by 0 form also. So if it is in the 0 by 0 form, we can use the L'Hopital rule here. Okay, now use the L'Hopital rule. If we use the L'Hopital rule, what is happening here? Let's see. Limit extending to 2. Try to differentiate the first. Yeah, Mansi Prajapati, anything you need to say? Nikhil Prajapati, Mansi Prajapati, what is happening? Why you are writing her name Mansi Prajapati? Your name is Nikhil Prajapati, right? Okay, so limit extending to 2, limit extending to 2, 3 raised to 2x plus 3 raised to 3. So differentiate the numerator first. So this will be 3 raised to 2x into ln of 3 into 2x ki derivative, that is 2, and plus 3 raised to 3 is 0 minus 12 into 3 raised to x into ln 3 whole divided by this will be 3 raised to x by 2 into ln 3 into x by 2 derivative is 1 by 2, this 0. Okay, so from numerator denominator you can see here all the ln 3 term will be cancelled out. This is ln3, ये cancel out होगा. Okay, so after cancelling from numerator and denominator, 3 raised to, sorry, ln3, what you are having, limit extending to 2, 3 raised to 2x into 2 minus 12 into 3 raised to x whole divided by 3 raised to x by 2 into 1 by 2. This is you are having till now. Now, if you'll check till now, can we cancel? Can we take this as 3 raised to x by 2 upon 2? Yeah. So this will be 3 raised to 2x into 2. It will take this to numerator. So what will happen? This will be minus x by 2 into 2 minus 12 into 3 raised to x minus x by 2 divided by 2. Limit extending to 2. So what is happening here? We are getting limit extending to 2. This will be 4x, 3 raised to 3x by 2 into 2 minus 12 into 3 raised to x by 2 whole divided by 2, right? Whole divided by 2 we are getting. So this is actually 1 by 2, na? Yeah. So if we'll put this now to the numerator, this will be limit extending to 2, 4 into 3 raised to 3x by 2 minus 12 into 3 raised to x by 2. So if we'll put the limit now, try to find. So this is 4 into 3 raised to 2 will be cancelled out. That is 3 raised to 3 minus 12 into 3 raised to 2 by 2. That is 1. So it will be 4 into 9, 27 minus 36. So that is 36 are right? Common is 3 square. If we'll take 3 square common, so this will be 12. This will be 12 minus 4. So 9 into 8. ऐसे कैसे हो जाएगा? कुछ तो गलती किए हम लोग. So check the answer, please. 3 raised to. This is the answer, no? Oh, this will be divided. Sorry. Actually, we need to divide this to 6. Okay, it will be 6. It will be 6. Okay, so finally, this will be 6. So 4 into 3 raised to 3 minus 6 into 3 is 2. Answer will be 36. This is your answer, guys. Okay, this is your correct answer, right? So by using L'Hopital rule, you can use or you can solve the questions easily. Like this is the best way when you are getting the form in the form 0 by 0 or infinity by infinity. Clear? Chalo. So let's move to another question here. This is the solution. Okay, now standard limit, you can use these limits also. When limit extending to 0, 1 plus x to the power 1 by x, it gives you 1. And also this is also extending to infinity 1 plus 1 by x to the power x is equal to e. These are two standard limits you need to remember. When extending to infinity 1 plus x raised to 1 by x gives you e. And 1 plus 1 by x limit, remember limit extending to 0, 1 plus dabba whole to the power 1 by box is equal to a. Then limit extending to infinity 1 plus 1 by box whole to the power box gives you e. So both the limits gives you e. Okay, whether it is only one box or it is 1 upon box. So when it is in the bracket box in the power 1 by a box, when it is in the bracket 1 by box, it is in the power box. So both the limits are having 1 as e as the value. Right. So this is the series expansion of 1 plus x to the power 1 by x, that is e into 1 minus x by 2 plus 11 by 24 x square. So remember this series expansion, so it will be useful in advance also. Okay, so these two standard results you need to remember. Now, generalized formula when the limit is in the form of 1 to the power infinity, and it is important, guys. Actually, it is important. Remember, mostly questions are asking from these concepts also. Maximum times I saw questions are asking from this formula. Directly remember the formula. When limit f extending to a f of x is equal to 1, limit another functions you are having phi of x that is extending to a. If phi of x is infinity, then the limit extending to a f of x to the power phi of x, if it is in the form of 1 to the power infinity, then the given limit is like this. So I am not talking about the formal definition, all these things. If remember, if limit extending to a f of x to the power g of x, okay, is in the form of 1 to the power infinity, is in the form of 1 to the power infinity, you are getting after substituting x approaching to a, then the limit will be the evaluation, the limit is equal to e to the power limit extending to a f of x minus 1 into g of x. Remember this formula, this is very, very important. This is very, very important formula. When the limit is in the form of 1 to the power infinity, then you can use it. That is e to the power limit extending to a f of x minus 1 into g of x. Okay, so let's solve one question here. See here, this is for your homework. You solve by at your home, because see, limit extending to 0. Okay, limit extending to 0, 2 minus cos of x and root of cos of 2x whole to the power x square, x plus by 2 by x square. Okay, so if you put the limit, this will be 0. Oh, sorry, this will be 1, this will be 1. So 2 minus 1 is 1, and this will be 0 plus 2 upon 0, that is 2 upon 0. So 1 to the power infinity. So 1 to the power infinity wala form you can use here. So how we can use? So just simple, we'll use the formula, that is limit, sorry, that is e raised to limit extending to 0 f of x minus 1. So what is f of x here? That is 2 minus cos x on root of cos 2x minus 1 into g of x, that is what is in the present in the power, that is x plus 2 by x square. So just evaluate this limit, you will get the answer. So how we can solve it? How we can solve it actually? You can use the series expansion of cos x, right? You can use the series expansion of cos x. So cos x का जो series expansion होता है, that is 1 minus x square by 2 plus x cube by 3, like this. So just take these two terms in place of cos x. So if we'll put e raised to limit extending to 0, 2 minus, why I'm not taking the higher degree of terms, because they are negligible, they are approaching to 0. So I'm just taking 1 minus x square by 2. So in place of cos x, I'm taking 1 minus x square by 2. And in place of cos 2x, I'm taking 1 minus 4x square by 2. Right, 4x square by 2 whole into x by plus 2 by x square. Now this will be easy to solve the calculation. This will be easy to calculate the things. Okay, now chalo, ठीक है. So if we'll solve these questions, if you have time, I can go, no problem. So see here, this will be limit extending to 0, 2 minus 1 minus x square by 2, and this is 1 minus 4, that is 2x square by 2 whole to the power 1 by 2 into x by plus 2 by x square. Right, now we'll simplify it. What you are getting, limit extending to 0, 2 minus 1, that is minus, that is 1 minus x square by 2 into 1 minus 4x square by 2. So this will be whole to the power 1 by 2. So this will be, we'll take the binomial approximations here. Okay, if we'll take the binomial approximations here, so 1 minus 4x square by 2 into 1 by 2, that is 2 cancel. Okay, so finally what we are having? We are having here x square. Okay, it is now, it is simplified. Very good. X plus 2 by x square. Now you can see here, it is very simplified form. It is a very simplified form. Okay. Now if we'll multiply these two terms, limit extending to 0. So what we are getting, that is 1 minus x square by 2 plus x to the power 4 by 2. I'm not taking this x to the power 4 by 2 because this will be very high. This is very close to 0. So this, I'm getting this into x plus 2 by x square. Now we can calculate, if we put 0 here, this will be 1. This will be 1. If we put 0 here, this will be 1. Okay. Okay, let's take limit extending to 0. This will be 2x square minus, 2 minus 2x square minus x square by 2 into x plus 2 by x square. So this will be to the power limit extending to 0. This will be 2 minus 3x square by 2 into x plus 2 by x square. कुछ तो गड़बड़ है भाई. कैलकुलेट करना ना, यू डोंट हैव टाइम राइट नाउ. इसको कैलकुलेट करना ना, कहीं से तो गलती, कुछ कैलकुलेशन हम लोग किए हैं. सो आंसर इज एक्चुअली 3. करेक्ट आंसर इज 3. Answer is equal to 3. Apply the formula, that is, this is important actually. This formula is important. You need to remember this formula first. This is very, very important. Then you can solve the questions easily. Right? ठीक है, clear? चलो, ये हो गया. By similar way, you can also solve this question. This is actually, if we'll put, if alpha is equal to limit extending to pi by 4, homework question hai, then this will be in which form? Tan of pi by 4 is 1. Tan of pi by 1 by 1. That is 0 by 0 form, na? Yeah. Pi by 4, x plus pi by 4. So cos of x plus pi by 4 is pi by 4 plus pi by 4. That is pi by 4, 1 by root 2. 4. That is 2 pi. Pi by 2, cos by root 0 by 0 form. Huh? So alpha is in the form of 0 by 0 form, and beta limit extending to 0 cos of x upon to the power cot of x. Oh, this is 1 to the power infinity form. So first is 0 by 0 form, second is 1 to the power infinity form. So use how to first find the value of alpha, then find the value of beta. Okay. By using the formula here, the second one can be solved by e to the power f of x cos x minus 1 into cot x. Okay. Limit extending to 0. है ना, तो इसका लिमिट हो जाएगा, this will be beta is equal to, you will get the answer as beta, you will get as the answer as beta as 1. Okay, so beta you will get a 1, and alpha you will get as, you will get minus 4. Okay, alpha you will get by solving this. This is by 0 by 0 form. Okay, by solving this you will get alpha value is minus 4. By solving this you will get the beta value is 1. Then alpha plus beta, then the quadratic equations whose roots are alpha and beta, na? So we need to substitute only the value of alpha and beta by using the quadratic equation. So what is the quadratic equation? Will be x square minus sum of roots. Sum of roots is 3x. plus product of roots, that is -4. -4 is equal to 0. So this is the answer. It's already given. This is the answer. X square minus 3x plus 3x minus 4 is equal to 0. And the values of AB, A is 1, A is 1, and B is -3. A is 1, B is -3. Option A is the correct one. Right? Option A is correct one. You can solve it by your own. How to solve by ये 0/0 form कैसे solve करोगे? How can you solve the first alpha वाला portion? By taking ये जो tan x है ना उसको हटा दो भाई. ये tan x को ही हटा दो, ये solve हो जाएगा like this. And देखो, I'm solving this first. Alpha is equal to, it is given the limit extending to pi/4 tan cube of x minus tan of x whole divided by cos of x into x plus pi/4. So how can you solve it? Okay, so if you'll take numerator common, tan x as common, so what will happen to tan x into tan square x minus 1 divided by cos of x plus pi/4. Okay, so this will be limit extending to pi/4. This will be a limit extending to pi/4. So we know when we'll put tan in place of x, pi/4, it gives you 1. So tan square x minus 1. Tan square x minus 1 can be written as sin square x upon cos square x minus 1. ये tan square x को ही हटाना है. Divided by cos of x plus pi/4 को we can write this as cos x into 1/√2 minus sin x into 1/√2. Yes or no? We can write or not? Okay. So this will be now simplifies to limit extending to pi/4. This will be sin square x minus cos square x divided by, this will be, what is happening here? This will be, this cos square x comes to the numerator, denominator cos square x into, this is cos of x. If we'll put pi/4 here, then it will be cos of x minus sin of x. Yes or no? This will be cos x minus sin of x. If we'll take this 1/√2 as common, and it will be multiplied with the numerator, this will be this. So you can see limit extending to pi/4. Sin square x minus cos square x can be written as sin x minus cos x into sin x plus cos x into √2 divided by cos square x into cos x minus sin x. So this will be cancelled out, and in the numerator we're having minus sign. So this will be limit extending to pi/4 minus of √2 sin x upon cos x plus cos x divided by cos square x. Right? So now if we'll put pi/4 here, this will be 1/√2 plus 1/√2. That is 2 upon √2. So √2 will be cancelled out. Minus √2 into 2 upon √2 divided by 1/2. Right? So this will be cancelled. This will be cancelled. The -1. So beta I am getting the alpha I am getting -4 होना चाहिए ना. Where we did the mistake? Can you check again? Finally we are having 2√2 ना. Oh, पहले से हमारे पास 2 भी एक था क्या? tan cube x √2 into, ठीक तो है, सही है. So 2√2 हो गया. Yeah. This is 1/2 ना. This becomes 1/2. So this is 1/2 2. तो आंसर आ जाएगा तुम्हारा क्या? -4. -4 यहाँ पे 2 एकड़ है. है ना, 2 so -4 will be your alpha and beta is 1, then you will get the quadratic equation, right? So this is the solution for this question. Okay, alpha beta mil gaya, then using the roots of this equation you can solve, right? Now how we can solve when the limit is in the form of infinity by infinity? Okay, so remember, when the limit is in the infinity by infinity form, dividing by the highest power, the method is dividing by the highest power or replace x with 1 by a. Right. First, if it is in this format, then divide by the power of x, highest power of x, okay, or replace x as 1 by y. Okay, x as 1 by y. Like if x is tending to infinity, okay, so if x is tending to infinity, this is the last portion. Let me check. Yeah, if x is tending to infinity, then y is tending to 0. So we can replace x is 1 by y here. Either you need to divide the highest power of x or replace x by 1 by y, then the question will be solved. Second thing is, if the limit is in the form of infinity minus infinity, right? If it is in the form of infinity minus infinity, then combine the two terms and get infinity by infinity or 0 by 0 form. So when you are having a question which is in the form of infinity minus infinity, so your first job to convert that form by combining the two terms to the form, convert to the form infinity by infinity or 0 by 0. Then you can use the L'Hopital rule also other rules you can apply. Okay, chalo, ठीक है. So like one questions we can take here. Here 2021 questions you can take. Limit extending to infinity on root of x square minus x plus 1 minus ax is equal to b. Then the order pair AB is equal to. Okay, so how you can evaluate this limit? It is actually easy questions. You can solve it also. We don't have time actually, but if you are waiting, then I must solve this. Okay, so this is the see what is the form of this limit. You can see here when we are putting limit infinity minus infinity form. The form is infinity minus infinity. So how we can solve it? Infinity minus infinity का form में है. So how we can solve it? And this is given also as b, right? So simply what I'm saying, okay, the limit given as limit extending to infinity on root of x square minus x plus 1 minus ax. So what I'm saying, just rationalize it. If you rationalize it, x square minus x plus 1 plus ax divided by also x square minus x plus 1 plus ax. Okay, which is given as b. Now, limit, the numerator becomes limit extending to infinity x square minus x plus 1 minus of x square divided by on root of x square minus x plus 1 plus ax, which is given as b. Right? Now see, after solving, what you are getting here? Just you have to use one logic. Logic क्या use करना है यहाँ पे? Now, if you put okay, in the denominator the highest power is 1. Okay, and the numerator the highest power is 2. Right? In the numerator your highest power is 2 and the denominator in the highest power is 2. 1. So to make this one, so what we'll do? Sorry. Okay, सो उसको कैसे सॉल्व कर सकते हैं हम? डिनोमिनेटर की जो पावर है दैट इज 1, न्यूमरेटर की जो पावर है दैट इज 2. So we can write this as, how we can write this as? Oh, if you'll put 1 minus a square is equal to 0, then a square is equal to plus or minus, sorry, a is equal to plus or minus 1, right? So a is equal to plus or minus 1. So in place of this, what we'll do, limit extending to infinity, this will be 1 minus a square ka whole square minus x plus 1 by on root of x square minus x plus 1 plus ax. Right. It will put 1 minus a ka whole square. So a square is equal to 1. This will be 0. So if you put a is equal to 1 or plus or minus 1, it will be 0. Okay, this is a square. X square, x square. Okay. ठीक है. चलो. So उसके बाद if we solve it, then this is equal to this. So limit extending to infinity minus x plus 1. This will be 0 now. This will be 0. Minus x plus 1 upon on root of x square minus x plus 1 plus ax is equal to b. Okay. Then if you put divide limit extending to infinity minus x by x plus 1 by x divided by, it will be x square by x1 minus 1 by x, 1 by x square minus a, right? This is equal to b. Now if you put the limit, this will be minus 1 upon 1 plus a, which is equal to b. So from here, if you put a is equal to minus 1, no value, so a is equal to 1. So if a is equal to 1, then b is equal to minus 1. Okay, so a is equal to 1, b is equal to minus 1 by 2. Now, if a is equal to b is equal to minus 1 by 2. So option B is the correct one. Option B is the correct answer. Okay. Now it's time to end your class here. L'Hopital rule को हम use कर सकते हैं यहाँ पे. ये 0 to the power cosec 0, 0 to the power 0 और infinity to the power 0 in form में है. So cosec 0 is actually, it is in the form of cosec 0, 1 by sin 0, 0. So 0, infinity. ये फॉर्म है, इजी क्वेश्चन है, इसको सॉल्व भी आराम से कर सकते हो तुम, इसमें कुछ भी नहीं है. ठीक है, ये क्वेश्चन को हम कैसे सॉल्व करेंगे? वी कैन सॉल्व दिस क्वेश्चंस बाय टेकिंग द लॉग. सो आई एम टेकिंग एल इज इक्वल टू लिमिट एक्सटेंडिंग टू 0 cosec of x whole to the power 1 upon ln x, right? So if you put log on both sides, this will be ln l is equal to 1 upon ln x limit extending to 0 ln of cosec x. Okay, so sorry, this will be here limit extending to 0 1 upon ln x into ln of cosec x, right? So इसको अगर हम if we'll solve it, so what we are getting actually the limit extending to 0, this will be 1 upon cosec x into minus cosec x into, by using the L'Hopital rule, by using the L'Hopital rule, because it is in the form of 0 by 0, right? And this upon 1 by x, right? So if it is 0 by 0, then limit extending to 0 minus x upon tan x. Okay, so this is equal to e to the power, so minus 1. So ln L is equal to minus 1. So L I am getting e to the power minus 1, which is equal to 1 upon e. The answer is 1 upon e. And the last portion, that is Sandwich theorem. Sandwich theorem is saying if h of x is less than equal to f of x is less than equal to g of x for all x belongs to R, then if limit extending to a, h of x is equal to limit extending to a, g of x is equal to L, then we can say limit extending to a, f of x is also L, right? So this is the Sandwich theorem, and this is one questions you can solve by using the Sandwich theorem also. ठीक है, चलो, तो thank you all, bye bye, take care everyone, चलो bye bye, thank you, thanks for your time, bye bye.